Okay, so we're going to be on lesson 5.3 today. And yes, my voice is still not great, so just bear with me because we do need to learn this. Um, Recalling with our quadratic function, the standard form is y equals ax squared plus bx plus c. And then we started to talk about vertex form. And so vertex form is for a quadratic y equals a times the quantity x minus h squared plus k. And so today's lesson is going to be taking a look at how do we go from our quadratic function in standard form over into vertex form. So what we are going to be doing is what's called completing the square. And so before we get to that, I want to make sure we understand what perfect squares mean. So remember from geometry, a perfect square is where all sides are of equal length and, being more technical, 90-degree angles. And so if we have, say, this quadratic of x squared plus 2x, let me go to some tiles over here. In order to make this into a perfect square, I need to take, I have my x squared term here, I have my two x's, and then I need to, there we go, take this and drop it here because then my sides would be x plus 1. So a side of x plus 1, thinking into our um, rectangles that we build. So in order to make that happen, I need to, again, to make this a square, I need to add one tile in here. So again, I'll draw this out over here, thinking of it in terms of our generic rectangles. This is my x squared. Here's my x tile. And then my other x tile needs to come down here at the bottom. And so this side is x plus 1. And this side over here is x plus 1. And so what I did is I needed to add this one tile to make this into a perfect square. And as a perfect square, so I needed to add 1. As a perfect square, this is the quantity x plus 1 squared, because again, I could write this as x plus 1, the length, times the width of x plus 1. And since these two terms are the same, it's x plus 1 squared. So taking that same idea here with x squared minus 6x, I have, here's my x squared tile. And in order to get this, my x's to be even on the side here and down below, I need to have 3 of these on the side here and 3 down here. So I basically took that 6x and I split it in half. And so this is x minus 3 and x minus 3. Well, in doing that, I am essentially adding in these sections here. And so how many tiles here did we add? We had to add 9 of them. And so it doesn't matter that these were a negative 3x here, because negative 3 times negative 3 is still positive 9. So x minus 3 times x minus 3. And so again, as a perfect square, this can be written as x minus 3 squared. Okay, but remember we had to add that 9 in order to make that into a perfect square. Okay, so taking that idea, the idea of completing the square, all right, we're going to have, one, we need to be certain. So this is a couple things to add here. Be certain you are written in standard form. And so making sure you're written in standard form, make sure that the first term is your x squared term, and that's your quadratic term. And then you have your linear term. And then finally your constant at the end. Okay, so just make sure. So the first step then would be to group the first two terms together, leaving a space. And those first two terms we're talking about are the quadratic and your linear term. Okay, so what this is going to look like is you're still going to have y equals, and then you're going to have ax squared plus bx plus that space, and then we're going to close that parentheses, and then we're basically taking that constant and kind of moving it off to the end. Okay, the next step is if there's a leading coefficient, we want to make sure that we factor that out. So the x squared needs to be a positive 1. And so most of the things we're going to do are not going to have this that we have to worry about. But we're going to be, if it did have an a, we need to make sure that it is written this way instead, where we would have the a in the front, and then it's x squared plus, and then it's not going to be b anymore. It'll be whatever b divided by a is, because we factored that out, and then plus our blank still. And then we're still going to have that c at the end. Again, these will be more of a challenge problem if there's going to be a coefficient for you to factor out. All right. The third step, I call this one like the side work, okay? So I always put a star by it, and then I call it side work. And so what this is this is what's needed to complete the square. You take b divided by 2, and then you square it, and that's what is needed to complete the square. So again, I call this the side work, okay? And then what we're going to do with this is we will have that we then add that amount. So this number here is what we're going to add to both sides. Okay, so what does that look like? And again, once we get into some examples, it should all make sense. We'd have the a in the front. We're going to have x squared plus our bx, or b over a, x term, plus this blank, and that number that we got from that side work, the b divided by 2, is what's going to go here on this blank, okay? And then what happens is, because we added that to the equation, okay, because we added that inside that set of parentheses, we also are going to need to subtract it outside of the parentheses. And so that's what this part is saying, subtract that. And if I had an a term, I actually need to multiply it by that too, because if there was a number out here, and it would distribute. So it'll be a times that number that I added to complete the square. Okay, so that value is what's going to be added and subtracted from the equation. So it's going to be added inside that set of parentheses and then subtracted at the end of the equation. Okay, and then we'll be able to write this into what is called our factored perfect square trinomial, which would convert it into its vertex form. And so a better way of looking at how this is converted is this part right here becomes x plus b over 2, and that's this value here. Whatever we got when we did b divided by 2, that value is going to go in here, same sign, and then we square it, okay? And then the other end parts will still come down. So I'll still have a in the front, and then I'll have whatever this value becomes at the end. So plus, and then we'll just call that our k. And so that's how it's going to be converted into its vertex form. All right, so I know those notes are a lot and it's confusing. So let's just get into it. It's going to be super easy once you start working it, okay? So first thing, I'm going to take my first two terms and I am going to put parentheses around it. I'm going to leave a space and I'm going to move that constant to the end. And then I'm also going to subtract whatever that value is I get on that line. Okay, so what is that value on the line? Well, the value is coming from b divided by 2 squared. And so our b is -4 divided by 2. And then we're going to square that. So -4 divided by 2 is -2. And squared is going to be 4. So we're putting 4 on the lines here. Okay. Now, let's simplify this down. The x minus 4, x plus 4 becomes a perfect square of x minus 2 squared. And again, we can take that from the idea of our algebra tiles. And if I have -4x, I have x, I've got 2 x's on the side there and 2 down below here. And then what is it that I needed to add to make this a perfect square? And that's where those 4 are coming from that we're getting here and here. Okay? All right, so continuing this, okay, we still need to do what is -5 minus 4, and that is -9. So y equals x squared minus 4x minus 5 in vertex form is y equals the quantity x minus 2 squared minus 9. All right, let's do another one. So again, number 2, y equals x squared minus 8x minus 14. Take the first two terms, group them together, and add a space. Take your constant outside of the parentheses and subtract that space. Okay, our side work that we need to do. Okay, so this is the side work. -8 divided by 2 squared. And again, that's how we complete it. So -8 divided by 2 is -4. -4 squared is 16. So I need to add 16 to complete this square. All right, x squared minus 8x plus 16 is a perfect square of x minus 4 squared. And so this part right here, whatever we get when we do the b divided by 2, is how that is being completed. So we have x minus 4, the quantity squared, and -14 minus 16 becomes -30. So y equals x squared minus 8x minus 14 in vertex form is y equals x minus 4 squared minus 30. All right, coming down, number 3 here. All right, we would group the first, so -x squared minus 4x plus 4. We would group the first two together. Okay. Oops. Plus a line Move my constant outside. Okay. Now, I have a leading coefficient that's not a positive 1. It's a negative 1. So what I need to do is I need to factor that negative out. And so in factoring that negative out, it's going to make this x squared a positive inside. It's going to make the 4x a positive inside. And then we're still actually going to be adding a term here. Now, when we have this on this side, because we factored a negative 1 out here, we need to remember that this is going to be a negative 1. So when I'm minusing, I need to remember that I have the negative 1 that I factored out. That's going to need to multiply by what I am adding to each side. Okay, so side work now. Okay, b, which is 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So we're adding 4 in the parenthesis, which means we're subtracting 4 out here. Perfect square, x squared plus 4x plus 4. The perfect square is x plus 2 squared. We have a negative in the front we're going to bring down. And then on the back end of it, okay, this k value, all of this here. All right, let's simplify it a little bit. I have that positive 4. The minus and negative part is going to make this a positive times that 4. So we're actually going to be adding 4 on that side. So this is going to give us a total of 8. So again, I can think of it this way. I had negative 1 here, and negative 1 times the 4 means that I really subtracted 4 within that. And so I need to add 4, do the opposite to it. Okay, so y equals negative the quantity x plus 2 squared plus 8. All right, number 4, we want to factor out the 2. We have x squared plus, we're dividing this by 2 also, 6x plus something. Move the constant to the end, and then we're subtracting 2 times whatever that number is. And the 2 again is because of this value here that I factored out. I've got to multiply that also. All right, my side work. Take your b, which is 6, divided by 2 squared. That's 3 squared, which is 9. So we're adding 9 inside that set of parentheses. And now in simplifying this, x squared plus 6x plus 9, the perfect square becomes x plus 3 squared. I have the a value of 2 in the front. And then on the end of it, I have a positive 1, and I have negative 2 times 9. So that's positive 1 minus 18, which is going to be minus 17. So y equals 2 times the quantity, x plus 3 squared minus 17. All right, and some of you might be wondering, why do I need to know about this? And so I'm going to show you a couple of things, or tell you a couple of things. One, this is just extra. You can add it if you want into your notes. But one, it's much easier to graph when you're in vertex form. Because again, if I know my vertex form, I know that my vertex, we'll do this one here. I know that my vertex is at -3, -17. So -3, -17. And then I know that my a value is 2, so I know I'm going to go to the right one and up 2, not drawn to scale here. And I've got a basic graph that I'm able to do. So it's much easier to graph with vertex form than it is to go through all the properties in standard form, because that's finding the axis of symmetry, calculating the vertex, where's your y-intercept, what are your x-intercepts, and then trying to graph off of that. So much easier to graph in vertex form. The other reason why this is really nice is because I can also solve in vertex form. And so remember, solving is where's your x-intercepts at? Where are these guys right here? And so that means when y is 0. And so when I'm in vertex form, especially if, I can still, one, this isn't factorable. And then two, I could do quadratic formula, but this is also where quadratic formula is coming from. I can use this to solve the equation. I can get x by itself. I can add the 17 over. This may not look too pretty, but, and then I'm left with 2 times the quantity x plus 3 squared. I need to get rid of this 2 over here, so I'm going to divide both sides by 2. So I have 17 over 2 equals the quantity x plus 3 squared. To undo a square, I would take the square root. So I can, again, take the square root of both sides. And when I do that, I have plus or minus, by the way. 17 over 2 equals x plus 3. And then I can continue this and get x by itself by subtracting 3 from each side. And so x equals negative 3 plus or minus the square root of 17 over 2. So I'm able to solve this way also. So again, just a little extra for you to know. All right, go ahead and turn the page. Let's go to problem 5. I'm going to show you a different way. So in reality, you can do either way as long as you're able to convert into vertex form. So this is a different way to be able to convert to vertex form. So a second way to convert. And for some of you, this may be a better way, and for some of you, maybe not. It's up to you. So a different way would be to remember that your axis of symmetry is found by negative b divided by 2a. So if my b here is 8, negative b, negative 8 over 2 times 1, which is negative 8 over 2, which is negative 4. This is my x value. Okay, and then how did we find our vertex? So remember we took our vertex is the coordinate point, that negative b over 2a was the x value, and the y value was the function of that. And so we took that and we could plug it into the equation to find the y value. And so the y became x squared plus 8 times x plus 10. And the x that we're popping in is what we found for the axis of symmetry, the negative 4. So plugging all of that into a calculator at once, remember your parentheses, especially on this first term, make a difference. I'm going to have 16 minus 32 plus 10. I'm not using a calculator, so that's why it's taking me a second here. It's negative 16 plus 10, so y equals negative 6. Okay, so our vertex is at the coordinate point negative 4, negative 6. And so if I know that, I can go ahead and use that to write in vertex form. Y equals, what's my a? My a is 1. So I can put that x minus, remember vertex form is x minus h squared plus k. So minus opposite for that. So it'd be x plus 4 squared and then minus 6. So again, just another way to look at it. I'll do that one more time over here so that you can see how it is. Okay, so axis of symmetry, negative 12 divided by 2 times negative 1, negative 6 over negative 2. My axis of symmetry is at negative 3. Hold on a second, negative 12. Hold on, little mistakes here. Over negative 1. Okay, so this is negative 12 over negative 2, which is axis of symmetry is at x equals positive 6. Okay, plugging that in. Negative 6 squared plus 12 times 6 minus 4. This term here, when I plug it in, is going to give me negative 36 plus 72 minus 4, 36 minus 4. Okay, so my y is going to equal 32. So my vertex is the point 632. And again, you can, in your calculator, plug this in exactly as you see it into your calculator, and you'll immediately get that value right there. Okay? All right, so writing this in vertex form, y equals my a is negative 1 times x minus my x value of my vertex, which is 6 squared, plus the y value of my vertex, which is 32. So in vertex form, it is negative the quantity x minus 6 squared plus 32. Okay, using whichever method you choose, go ahead and do 7 and 8 in your notes and get it into vertex form, and then go ahead and graph it and identify those other characteristics. Hopefully this wasn't too painful, and we'll continue to go over this tomorrow when I return.